Hey everyone, I'm Michael Wishart. I'm the go-to-market specialist for observability and governance, affectionately known as cloud operations. We're really excited to spend some time today to walk through customers how AWS has native capabilities for customers to be successful with their EKS deployments. I think it's, for a majority of the folks that are on the call, everyone's well aware of the excitement they have for EKS technologies and how that can help them scale their respective businesses and reduce risk. I'll let my co-hosts introduce themselves as they go through the session, but as a quick overview, this will be led by myself, Michael Wishart, as well as my esteemed colleagues who are technical experts in their respective fields, Siva, Jagan, and Ganesh. So really excited. We have a lot of content to go through over the next couple hours. For the first 30 minutes, Siva will walk through cloud-native observability with tools like Amazon CloudWatch. And after that, my colleague Ganesh will then touch on our managed open source offerings for EKS observability, such as Amazon Managed, Prometheus, and Grafana. And then lastly, on the governance side, I'm really excited to have Jagan touch on how you can ensure governance and compliance for your EKS workloads. So with that in mind, I will like to start off the call just with a quick poll, if that's okay. So let me see, it's my first time doing a poll with WebEx. So let me see if I can be successful here. We'd love to get a sense of how familiar folks are with the AWS's native observability capabilities. So let's see here. And once we do this poll, I'll pass the baton to Siva to kick off the observability portion.
Good. Thanks, Michael. Let me share my screen. Let me know if you're able to see my screen.
Yes.
Yep. Thanks.
Yes, correct.
Yeah, so let's get started. Thank you everybody for joining. Good morning, good afternoon, and good evening, wherever you're joining. My name is Siva Guruvarediyar. I'm a senior specialist architect focusing on monitoring and observability. And today, for the next 30 minutes, I would like to talk on the topic EKS observability with AWS CloudWatch. So first, let's ask the question of why we need to talk about observability, especially if you wanted to run any workloads in EKS, right? So the thing is, as our famously Dr. Werner Vogels, who is the CTO of Amazon, famously mentioned, everything fails all the time. So you need to mention, whenever you're running any kind of workloads, whether it is application workloads or even your infrastructure, that happen to fail for most of the time. So how we are going to be observing it and monitoring it. So let's start with the application layer, right? So especially after this microservices era, the applications are becoming too complex to manage today because there are a lot of programming languages. There are a lot of database types like SQL databases, NoSQL databases, and then we have message brokers like Kafka. So even a typical request that is coming from the customer is going through multiple hops written in multiple programming languages, multiple frameworks, and multiple databases, etc. So when these things are getting complex, how we are going to be managing it, right? So with this one, we have the complexity challenge because currently everything is distributed in nature. So if you wanted to scale it out, or your development team wants to deliver the features quickly, and then especially with container-based infrastructure, everything is ephemeral. So containers can come and go. And then if you're using auto-scaling groups, so even your nodes can come and go. So how you're going to be taking this complexity challenge? And moreover, when you're working on and building something in production, and then something is failing, and you wanted to reduce your mean time to detect and then mean time to resolve as quickly as possible, and possibly find the root cause in just a couple of clicks instead of going through multiple hops to find out the root cause. So how we are going to do that? And then if you are doing that, what is that thing you're getting it? If you are having a better visibility on your observability portfolio, so not only are going to understand your application health, and then not only are going to get an improved performance and availability, so it is going to be directly and indirectly reduce your operational cost. And also end of the day, we are all running some business. You will be improving your end user experience. So far so good, we know the benefits. But typically when I'm talking to the customers, majority of them are saying hey, observability is not new, we know that, and then we have been working with different tools for the past decade. How do we know what kind of maturity we are having in our observability layer? So that's when from AWS we have the observability maturity model. You in your x-axis you are having the capability, and then your right y-axis you are having the maturity. So starting with your step 1, we call it as a foundational monitoring, wherein you are collecting all the application signals, whether it is logs or metrics or traces. So that is the foundational monitoring. And going to the next level, you wanted to go with the intermediate monitoring, wherein you are instrumenting your telemetry analysis, and then you are having some insights over what is going on in your system. And in step 3, we call it as an advanced observability, wherein if you are able to correlate all your metrics, logs, and traces efficiently, and maybe if you are having any anomalies, you should be able to detect it. And moreover, you should be able to set some service level objectives to making sure how your services are running, etc. So those kind of things we call it as advanced observability. And the step number 4, which is the top layer, is going to be with the recent advancements to the AAML field. So if I can do some proactive observability, can I detect something even before something occurs, or proactive root case analysis and identification, and possibly if I can do some kind of remediation. So that's the maturity we are talking about. So we do have some questionnaire and all around it. So please talk to us, your AWS account teams, to know more about this. And we will be talking especially this stage 2 and stage 3 with the APM or applications performance monitoring, especially on the context of EKS. So with this one, we talked about the maturity model. So what are the offerings that are available from AWS? So we do have the breadth and depth of services, starting all the way from your instrumentation layer. So you do have your CloudWatch agent and embedded metric format. And then the foundation layer is you are having your metrics, logs, and traces, which you are collecting it. And on top of it, you are having a lot of visualization options, whether it is coming from CloudWatch dashboards or Metric Explorer, or if you are running cross account observability, etc. And then on top of it, if you want to find some insights that you're having it, if you want to have container insights, etc., that I'm going to be demoing today, and then contributor insights, and if you're running Lambda insights, etc., we do have that option as well. And last but not least, if you wanted to have a digital experience monitoring, that's where your application performance monitoring is coming into picture. And with application signals, we wanted to integrate all these things, including your synthetics, the real user monitoring, and then internet monitoring, everything together. So in addition to that, you do have your partner integrations OpenTelemetry, and then your third-party tooling, etc. So that option also available for you. So with this one, what are the things, if you're running some workloads, and then if you wanted to monitor some of the metrics, there are tons of metrics going around. So we have something called the golden signals, how many requests are coming in, and what is my average latency for a request. And then if there are any faults or errors that are there in my application, how we are going to be monitoring it. So these are all the golden signals we are talking about in terms of applications performance monitoring on top of EKS. And that's what we are going to be talking more in detail. So with that one, let me introduce the application signals, which is an offering that was introduced last reInvent. And then using application signals, so that is AWS opinionated way to do this applications performance monitoring. So under the hood, how it works is you are running your container workloads, whether it is EKS or ECS, or even you are running your workloads on top of EC2. So with that one, if you're running some of the popular programming languages like Java or Python, so your applications are coded and then it pushed to these containers. So what you need to do is just enable these application signals. So under the hood, it basically uses the OpenTelemetry as a mechanism, and you don't have to make any kind of code changes for this. So it is leveraging the OpenTelemetry's auto instrumentation layer, and using that one during the runtime, it is going to get all the metrics, traces, and logs, and using the Amazon CloudWatch agent, which is a unified CloudWatch agent, which was introduced lately. Using that, it will be sending all your metrics and logs to CloudWatch and your traces to X-Ray. So when all these signals are in place, your CloudWatch application signals, when you're going and then seeing that from the dashboard, so not only you can visualize what is going on in your system, but also there are a lot of pre-built dashboards that you can use it to assess the health of the system. And then you should be able to set some SLOs, and then you can even correlate your traces, metrics, and then logs in one place. And not only that, if you are having any kind of synthetics running or real user monitoring running, everything can be combined together in one place, which I'm going to be demoing it in a bit. So with this one, how it is being done, right? So let's start with the telemetry, how we are collecting the telemetry. As I suggested, this is using the OpenTelemetry as a mechanism. So you don't have to worry about you're doing a vendor lock-in, because OpenTelemetry is an open standard that is coming from the Cloud Native Computing Foundation, and everything is layered on top of OpenTelemetry. And with that one, we are supporting both X-ray as well as OpenTelemetry tracing. And not only that, because of the unified CloudWatch agent, you don't have to worry about running a lot of agents now. Maybe one agent to send the traces, one agent to send the logs, and then one agent to send the metrics. I mean, that story is over. Now you need to have only one agent, that is a unified CloudWatch agent, which has the capacity to take all these metrics, metrics, logs, and traces, and then send it to the destination. And also, it is backward compatible. So it just the unified CloudWatch agent is a drop-in replacement for the existing CloudWatch agent that you're running, which is running millions of hosts today. So the second one is you can discover the services. So you are running a Java application, and then you just enable the application signals that is running in your EKS infrastructure. So with that one, once you're coming to the dashboard, without you doing any kind of undifferentiated heavy lifting, you will be knowing what are the different services are running, how many endpoints are there, and then moreover how the dependence services are running. You don't have to do any kind of instrumentation on top of it, because everything is taken care with the OpenTelemetry auto instrumentation. So with this one, you will be able to discover the services, and also with this information, you will be able to troubleshoot with metrics and traces. So once you're coming here, you will be able to see the different services running, and then the golden metrics, and just a quick couple of clicks, if there are any kind of troubleshooting you need to do it, you should be able to do it. And then the fourth and important point is I wanted to set some SLOs or service level objectives. How I can do that? So to put everybody on the same page, I just wanted to take a moment and then talk about the difference between SLI, SLO, and SLA. So when your services are running, so it is emitting some metrics. So that's when we can set some SLI or service level indicators, which says my request count could be more than 200 or something, so it is able to withstand one. So that we call it as an SLI. So SLO or service level objective is driven from this SLI. And once you have an SLO or service level objective in place, which might be my service is going to be up and running for 99% of the time in a rolling window of 30 days. So that could be an SLO. So with that SLO, you can create an SLA, which is a business term. So that's what you will be informing to your customer. And whenever you are breaching your SLOs, there will be some kind of monetary implications or penalties will be there. So I just wanted to take a moment and then difference between SLI and SLO and SLA. With application signals, you should be able to easily set your SLIs and SLOs. For example, let's take a quick example. So I wanted to set an SLO of 99% of availability in a 1 month time period. In this 1 month window, let's take okay, if I'm setting 99%, it should be available. So that means 1% it can go down. So how I'm going to do that? In a typical month, like, we are having like 43,800. So one person is going to be like, 430 minutes. So that is roughly equivalent to 7 hours and 18 minutes. And that's what we call it as a error budget. So if it is going even beyond like, 7 hours and 18 minutes, so that's when like, we are breaching our SLOs. So far, people have been using like, complex calculations and then spreadsheets to come up with this figure. But with application signals, with a bunch of clicks, like, you should be able to set your SLIs and then drive your SLOs. And last but not least, again, synthetics and client integrations. If you're running any kind of synthetics or like, client integrations using real user monitoring, it is pretty straightforward for you to integrate this with application signals. So with that one, like, so far we about the application layer. So what's happening like, in my EKS layer, how I'm going to be finding all that information. So we wanted to make that particular thing easy for you without you doing any kind of undifferentiated heavy lifting. So that's what we have with something called Container Insights. So Container Insights is a fully managed and automated container observability. And if you are running like, especially in EKS, it's just an add-on, and then you just enable the add-on, and then without you doing any kind of work, all your metrics logs will be collected, aggregated for you for easy analytics. So with this one, like, when you're coming for the first time, like, out of the box, you will be seeing all your kube state metrics, control plane metrics, all those kind of things. And then you can have like, end-to-end observability using cross account as well. And as I mentioned, like, you just enable this add-on and that's pretty much it. You don't have to do any kind of changes and everything is available for you. So we talked a lot about this thing in theory. Let's take a moment and then see in practice how it is going to be looking. So when you're coming for the first time in CloudWatch, under application signals, you'll be able to see like, there are so many options available for you. Okay, so now assume like, I have enabled this application signals. When you're coming for the first time, you'll be able to see like, this button that is enable application signals will be there. Just click on it. So under the hood, like, what it is going to do is it will deploy the unified CloudWatch agent and with OpenTelemetry if you are using like Java and Python. So those are all the two languages we are supporting today, and then many more languages in the pipeline, including .NET and JavaScript. So once you have done that using OpenTelemetry, all the metrics, logs, and traces will be collected automatically. And then using the unified CloudWatch agent, it is going to be sending that to CloudWatch. So once you have done it, and then all these metrics are available for you. So this is how you will be greeted when you're coming for the first time. Starting with like, the SLI status, how it is healthy or unhealthy, then fault rate by services, by path, etc. And then the different services that you have it that is running in your EKS infrastructure, everything will be combined here. And then if you go further down, all your golden metrics, like, the logs, the volume of request, and then false, and then error rate, all this information are available from one place. So not only that, like, if you wanted to holistically see what's going on in my application, you can click on the service map, and then it is going to show you like, your front end, and then how it is being done, like how your front end is calling your back end. All this information are available. So let's take a look into like, just click on some edge, and then it is going to show you like the request, and then what is the average latency, the error rate, fault rate, etc. And then if you set any SLIs, whether they are unhealthy or healthy, and then the details of that application. So currently it is deployed in an EKS cluster. So this could be running an ECS or EC2 also, right? So currently this is running in an app signals demo cluster with this particular default namespace, and then this workload, etc. All that information is available for you. And then if you click on any of the edges, so that is going to give you like, what are the top 3 paths by failure, latency, etc. And then all this information are available from this place as well. So let's go back to the services. Like, once you have done that, let's see like how you can create a SLO, right? So we have been talking about like, SLOs. Assume like, you're coming for the first time. So this is a typical pet site application, and just demo application, wherein like, you can bring in your pets and then for taking treatments, etc. So today we are supporting like, 2 different ways you can create an SLO today. First one is like, the legacy or like, the CloudWatch metric. So if you don't want to rely on this application signals, and then if you are already having like, some CloudWatch metric going on, and you wanted to set some SLOs on top of it, just choose that option and then select the metrics. For example, like, let's go into like maybe application load balancer and then per ELB metric. And my intention is going to be like, I wanted to take my request count, and then I wanted to see like, how many requests are failing, so that I will be knowing like, okay, so these are all the number of requests that are passing, like, maybe take the 500 request. So with this one, I will do this, go to your expression, because today we are supporting on only one metric you can create an SLO on. So my M1 is going to be request count and my M2 is going to be my 500 errors. So what I can do is, okay, I will say like M1 minus M2, M1 minus M2 divided by M1. So this is going to be giving me like, my request count minus my 500 errors divided by my request count. This is going to be showing you how many requests are actually succeeding without any kind of server errors. So now I got some things. So I can use this E1 as my expression, and then I can choose the select metric. So with this one, like, let me set my SLI here. So currently it is like, 0 to 1 range. So I wanted to make sure like, the set condition should be like, it should be less than 1. Like, that's a metric that I wanted to do it for my SLI. So once you create this SLI, you can go ahead and then create the SLO as well. I will say like, 1 day rolling window period. I can say like, it should be available for 99.9% of the time. And then if it is going beyond that 30% threshold, I want it to be warned, right? So you can have this kind of a thing. And then today we are supporting like, you can set CloudWatch alarms in 3 different layers. One is on the SLIs, health alarm, and then the second one on the SLO attainment goal alarm. And then the last one is going to be like, whenever, if it is going beyond that 30% threshold, if you want to be creating a warning for that, you can create it and then do that. So this way, like, it is very much easy for you to create a SLO and then do that. And once you create an service operation, like, I have enabled my application signals and I wanted to create an SLO for that. How can I do it? So once you enable it, like, without you doing any kind of work, so just click on that operation. And as you could see here, like, I'm running a lot of workloads here, both EKS and EC2. So let me choose this EKS pet clinic frontend. So if I'm interested in like, this particular visits, because as a business owner, I'm more worried about like, people come and visit me. So that's the way like, I'm making my living. So I want to make sure like, this particular endpoint should be having an availability of 99.9% of the time. So once you have done that, it's going to be showing you in easy English, like, so this particular service level objective, we have set it for this particular endpoint, and it should be available for 99.9% of the time in a 1 minute period. I'm done with my SLI. So now I can go and do an SLO here. Again, I can go and set it like, in a 1 day rolling window. I want to make sure like, it should be there for 99% of the time. So that means our error budget is 14 minutes. So 14 minutes, it can be like, not available, but beyond that, like, if it is there, then my SLO is breached. And again, I can set it like, a warning threshold, like, 30%, if it is going beyond that, I can create a warning, etc. So with this one, like, you can easily create an SLO and assume like, I have done that one, and then I'm running this particular thing in production, and I'm coming for the first time. So this is the first one is like, scheduling a visit. So that's what we were talking about, right? And then I set a goal of 95% of the time it should be available. So currently it is showing in red because it is unhealthy. And then it is an ending error budget of like, it is going beyond that particular threshold. I have done it. So let me do some troubleshooting. Maybe I should not go beyond a 3-click. So how I can do it? So just click on that particular operation. So now it is, sorry, yeah.
Oh, no worries. We have a question from the audience. Can this be consolidated? Can this be consolidated metrics from different clusters hosted in different AWS accounts?
Cross-account observability, yes, you can do it like, provided if you're running CloudWatch, you can send that as a metric, and then whatever you can do it with CloudWatch, you should be able to do it.
Sure, thank you.
Is there any other question, Michael?
None at this time from the audience. I'll monitor the Q&A.
Nice. Yeah, so let's proceed further. So currently we just came into this particular /visits endpoint. And then from here, like, I wanted to know what's going on. So I'm seeing like, some spikes in my latency, etc. So just click on one particular spike. and then it is going to bring up all my traces at that particular point in time. So as you could see here, I can able to correlate all the signals. If you see the left-hand side, I'm seeing my metrics, and in my right-hand side, I'm seeing my traces as well as my logs. I can easily correlate like what's going on. And interestingly, like, at that particular point in time, I'm seeing my traces, which are having like, 500 errors. So let's see like, what is going on. So there's a second click we have been doing. And now from here, like, I can see like, okay, my client is sending like, this is a lineage of my request. It's going to be a proxy and then front end and then my visit service. And finally it is going and hitting a DynamoDB table. So from here, like, I can easily see there are like a lot of 500 errors which are coming in. And then from this way, like, with just 2 clicks, I should be able to know where exactly my request is failing. On top of it, like, if you wanted to get into the details of where exactly it is running, so just click on that one, and then it is going to take you to my enhanced container insights page. So since I'm coming from the application signals page, all those things are like, predefined filters are already applied. So I don't have to worry about where my cluster is running, which namespace it is running, etc. All these things are already populated for me. So from here, like, I will be coming here, and then I can easily see like, what's my pod percentage, CP percentage, etc., memory utilization. All these things are available for me. So we are having like, talking about 2 different personas. For example, if I'm an application person, I should have started from my application layer and going all the way and then landing into my infrastructure layer. If I'm a DevOps person, I'm more worried about like, running my infrastructure. So in that case, like, I will be starting with this layer, like, container insights. So when I'm coming for the first time, so this is how I will be greeted, like, my clusters on a high level, like, how it is behaving, etc. And then my kube state metrics, my control plane metrics, and what are my top 10 contributors in terms of like, nodes, workloads, pods, etc. in terms of CPU utilization, memory utilization. All this information are available from one place. And my intent is currently like, there is a cluster running. So I just wanted to go ahead and then get into my cluster details. Now, if you can see on a high level, if I wanted to see from cluster level, I can see that. And all the way to my container level, whether it is a micro view or macro view, I should be able to do it with like, applying some filters based on like, what kind of information I wanted to get it from here. So with this one, like, I'm a DevOps person and I'm seeing all over the place, like, things are going okay. And coming down all the way down, I will be able to see like, a couple of tabs. So here, the second tab is the application signals tab. So as a DevOps person, I can come over here and then see, okay, I'm seeing some of the services are running unhealthy. So I wanted to dig down into like, what's going on. So I just click on it. It's going to take me back to the application signals page. So it doesn't matter whether you are starting from application layer or infrastructure layer, you can traverse all the way, both like, application to infrastructure or infrastructure to application easily. And that way, like, you can get your end-to-end visibility in a very easy manner. So getting back to our thing, like, so we identify like, some of the things, okay, and what happens, like, why my synthetics or like, how my synthetics are running, or how my dependencies are running, even though my SLO is breached. So if you wanted to know all this information, you can go to the dependencies tab. And from here, like, you will be knowing all your dependent services. As you could remember, like, this particular visit service is talking to a DynamoDB table. So it will say like, the put item call, how the latency is going on, like P99, P90 latency. And if I'm running like, any other services, how it being done, every information is being tracked from here. And the other thing is like, synthetic canaries. If I'm running any canaries from here, like, I will be able to see from here, at least for the visit service, which is a backend service, I'm not running anything. And then if it is a real user monitoring, if it is a front-end application, from here, like, I should be able to see what's going on in my application, like, how many requests are, like, I have run it, and then how my users are seeing the pages, what is the latency, etc. All those things, like, you should be able to see from one place. So all these applications, like, if you go to this application signals, all the options are available for you. So if you are interested only in synthetic canaries, you can go in there as well. So it is not necessary that you have to go through these application signals and get into your page. For example, like, I am running like a pet clinic RUM. So that's my real user monitoring. And from here, like, you can come over here and then you can say like, how many steps I have executed, and what is the latency, and then if there are any issues, so just click on it, and then all the screenshots are available for you. So currently, as you could see here, I have run some steps and we have failed, and then the screenshots are taken for you. Those kind of information are also available for you. So again, putting things in perspective, we are nearing the 30-minute mark. To summarize it, like, if you are running an EKS infrastructure and then running some workloads on top of it, and if you wanted to enable this observability on top of it using AWS native way, so these are all the options for you. You can enable these application signals, and especially true, like, if you're running an EKS, it's a simple add-on. You just need to enable that add-on, and that's what you need to do it. And that's pretty much you will be doing it. And then under the hood, like, it will be taking the unified CloudWatch agent, it will be deploying it, and then the open telemetry also, like, deployed for you. So without doing any kind of manual instrumentation, using open telemetry as a mechanism, we are taking all the metrics and traces and then sent to the CloudWatch. And with enhanced container insights, you'll be knowing, like, what is going on in your application in an easy manner. So now let's go back to the presentation. So that's pretty much I have it. So if you wanted to do more into that, so we have a lot of free resources. One is a one observability workshop, and then the best practices guide. So you can go over here and then try and see, like, all these things, whatever I mentioned to you, like, they are available for you. You can take a look into it. All the documentation are available. And one more thing is, like, we do have something called Observability Accelerator. So if you're running any kind of infrastructure as code, like, Terraform or CDK, this accelerator is going to be like, accelerate the experience so that you don't have to write anything from scratch. So you can just take those things, identify the pattern, like, I wanted to run maybe an EKS cluster in one particular account or multi-account, etc. So just identify the pattern, and then depending on the IAC of your choice, whether it could be Terraform or CDK, just take it and then run it. And finally, we do have, like, some skill builder courses as well. Some of them are free. And then we do have, like, AWS observability course as well. So these are all some of the resources for you to work on. So with that one, like, let me hand over the mic to Ganesh, who is going to be talking about the observability in terms of open source. Thank you, team.
Thank you, Siva. Let me share my screen.
Ganesh, while you're sharing your screen, I just want to share the poll from earlier today, from earlier in this meeting, where it looks like the majority of folks here are evaluating products for container technologies within the past year. So really excited that this is of interest. I will share another poll while Ganesh gets started around, just to get a sense from the audience, what are some of the biggest challenges that customers are having with regards to EKS observability. So Ganesh, the floor is yours. I'll just have this poll be going in the background.
Are you able to see my screen, Michael?
Yes.
Awesome. So hello, everyone. Good morning. I am Ganesh Sambandhan, Technical Account Manager with AWS. I'm also a Cloud Operations TFC member, focusing on open source observability. This happens to so many of us. As we operate our services on container environment, most of the time things go wrong, we get paged, and ideally what you want is that you get paged, you have a way to react to it, solve that problem, move forward, and get back to bed as quickly as possible. So everyone wants that. So to be able to do that, the main requirement is to have the detailed observability tools, configuration, dashboards, all the data in place so that whenever something goes wrong, you can dive deep and understand the issue and fix it as quickly as possible. But we have heard from our customers that having proper observability, alerts, dashboards, and the right data is a difficult challenge, especially for container environment. So to solve that problem, back in 2019, we launched Container Insights. So this functionality, basically, it gave us some of the dashboards, out of the box dashboards, alerts, and other mechanism to monitor your container environment. And around 2020, based off of popular demand, we launched the Amazon Managed Service for Prometheus. It's a famous open source time series database to store millions of metrics, and it's very popular in CNCF projects. And with that release, we released many features around Amazon Managed Service for Prometheus. Customers were able to deploy their Prometheus monitoring, all the node exporters and container monitoring on their cluster, and push all the metrics to Amazon Managed Service for Prometheus. And then they are able to scale the metrics and view it through the dashboard mechanism. Then in around 2023, we enabled enhanced container insights, where we enabled additional metrics for deep insights into your cluster and all the other, the alerting mechanism and everything. So during the reInvent 2023, we launched Agentless onboarding for managed Prometheus. So basically, we understood that managing the agents, the Prometheus configuration, scraping files, all the JSON, everything is extremely difficult, especially when you have hundreds of clusters in your AWS environment. So we introduced this feature where we covered all the configuration for our customer. And basically, it's a one-click solution to enable Prometheus monitoring on your EKS cluster and push all the metrics into your time series database. So I am sure many of you would have seen this image during our conference and other summits. So basically, this slide covers all the observability tools and functionalities that we provide to our customers. So here we have native services, where we have CloudWatch Service Lens, Container Insights, Lambda Insights, Contributor Insights. So basically all the APM and infrastructure monitoring with native services. And here you have open source managed service, where we provide Amazon managed Grafana for the dashboard and data analysis visualization tool. And then we have OpenSearch service, and then Amazon managed service for Prometheus. So those are the most popular open source managed services we provide. And then the collection mechanism, where we have CloudWatch agent, fluid bid, and collectors, where we use this mechanism to push all the metrics into either CloudWatch or to the Prometheus to collect all metrics. So now this session covers the open source observability. So why open source observability, right? So it's closely developed with Kubernetes, and it has so many functionality, expandable, scalability. So with open source observability, with AWS managed services, the security first is our key priority. And then you can use this open source tools in the production workloads. It will be like highly scalable, efficient, and it's able to manage your scale workloads. And then seamless integrations, right? So if the open source tool is like AWS managed, you get all the benefits of AWS integrations, like you can enable event bridge, alerting mechanism, dashboards. So that will be a great benefit for our AWS customers. And then, of course, open source contribution. So whenever we use this tool and we provide the managed services, we also contribute back to the open source community, and it will help the tool, with a lot of functionality and fix all the bugs and issues. So as I discussed in the beginning, like the challenges in container observability, of course, onboarding barriers, installing agents, configure your clusters, it will be a big challenge. And then again, once you configure everything, the next step is what metrics to collect. Especially with Kubernetes, EKS, there are like ton of metrics you can collect, but you want to know what are the key metrics to collect so that you can identify and find the root cause for the issue. Then, of course, based on the data, you need to identify the impact analysis. And then, of course, the opinionated observability to overall. So the problem is like you have, again, the same issue. You have so much data, but you need to understand how to design your dashboards, how to design your alerts, right? So, and then, of course, cost of observability. So whether are you getting the right benefits out of your data? That is a key criteria for the customers. So with that, I would like to talk about this open source agentless collection where we will solve many of the challenges. So how this process works, right? So your AKS cluster, while creating your cluster, you can create the Prometheus agent collection with a single click. I will show it in a demo in a few minutes. So you can just enable that Prometheus, all the scraper config and the endpoints, everything is configured by default. And once the cluster is created, the AMP, the Amazon Managed Prometheus workspace is created automatically. If you have an existing Prometheus workspace, you can use it, or you can create a new one. It will be automatically created. And then you can use Amazon Managed Grafana to visualize the dashboard. So before before this agentless connection, you need to manage your collector, your scrape config, everything in your cluster itself. But now with the managed services, all the heavy lift is like moved into the managed service area. So you can see here the collector, injector, query. So all the configurations are happening in the Amazon Managed Service for Prometheus section. So it is easy for customers to enable this monitoring with a single click. And then when you scale it to hundreds of clusters, right, this whole process gets super easy as well. So I want to talk about some of the benefits of Prometheus collectors and why it is super popular in EKS and Kubernetes area. So it's serverless. So once you create a workspace in Prometheus, it is highly available, fully managed service. It's a secure thing, right? So you don't need to manage your highly available clusters for your Prometheus. So it's automatically store your metrics in a highly available manner at the back end. And then of course there is no upfront fees. You don't have to provision your storage in advance. So it's based on your number of metrics. Push it into your Prometheus cluster. And the Prometheus is like you can store millions of metrics in Prometheus cluster in a highly available manner. So the benefit is like you can store metrics for many clusters in a single workspace as well. And of course, you can monitor the Amazon EKS environment at scale with the different regions and different AZs. It will be easier for you to monitor all the cluster. And then here we want to talk about Amazon Managed Grafana. So I collected this metrics some time back. So now if you check the Amazon Managed Grafana document, you may see more number of data source, apps, panel, all the additional functionalities added. So open source, the Amazon Managed Grafana is a most popular visualization and the data analytics tool. So basically what you can do is you can integrate all the Amazon data sources. For example, you can connect your Prometheus, CloudWatch, X-Ray, and even it has it has extension for the third-party tools as well. So you can integrate, you can visualize both your AWS monitoring as well as the third-party monitoring tools in a single platform. So it has all the most of the data sources are available, and it has wide dashboard plugins available to design based on your requirement. So now that you enabled agentless monitoring, you have Grafana setup, you pull all the metrics. Now, the next big question is what metrics to collect, right? So to assist our customer, we created the observability accelerator. Shiva also talked about this about this tool in his presentation. So basically, the open source, it is open source compatible, of course. The observability accelerator is a set of opinionated Terraform modules. So basically it will help you to set up observability for your AWS environments with all the services, AMP, Grafana, even with OTel, the Open Telemetry tool. So what it does is like with all the best practices, all the knowledge of AWS, we provide curated metrics, logs, traces, collection, alerting rules, and Grafana dashboards for your infrastructure. So with this module, you can easily deploy this accelerator into your existing cluster or the new cluster. And by deploying this, you have an environment where you see all the key metrics in your Grafana dashboard, and also all the alerts and other mechanisms. So with that, and there is a QR code, so it will directly take you to the GitHub page of the observability accelerator. So as we discussed, right? So these are the benefits of enabling open source open source managed monitoring tool, easy onboarding, all the metrics needed for troubleshooting. By maybe you can use the observability accelerator, and if you enable all the CloudWatch tracing and everything, you can have end-to-end application monitoring and opinionated observability with best practice alarms. As I said, like with the observability accelerator, you'll get all the features, and then cost effective pricing. It's like basically it's expand as you want. So with that, I can quickly demo the EKS and how you can enable this agentless monitoring. So here, when you create a cluster, I already have a cluster, but let me create a quick one. So when you create a cluster, you provide all the basic information. By the way, you can enable this using API, CLI, EKS Kernel, all the functional, all the existing mechanism. I using the management console to show this functionality. So you can select all the basic uh, details, and then you can see use the default VPC, subnets, endpoints. So when you go to the metrics section, you will have an option to select the send Prometheus metrics to Amazon Manage Prometheus. So with this one click, what it does is like it will create a new workspace. If you don't specify the existing one, it will create a workspace for you, and it will manage all the scaper configuration. So this configuration is basically is how you monitor your EKS cluster with all the endpoints, the C advisor, where it provides all the collector level metrics. So all these things are pre-built for you. So you can use this default configuration, and then you can choose the AWS add-on, and then with all the basic information, you'll see all the option. And then once you create, it will take, I think, 15 to 20 minutes to create the cluster, but I can show the existing one. So here, once the cluster is created, you can go to this observability section where you will see the scraper ID. If you drill down, it will show the scraper ARN and the workspace ID. This is nothing but Amazon Managed Prometheus workspace and all the information, how we are collecting scraping metrics from your cluster. So once you click this workspace ID, it will take you to the Amazon Managed Service for Prometheus, where you can see all the information, endpoint URL, the remote write, and all the rules management, alert manager. You can create alert manager alerts, all the information. So once you have this information and once the metrics are flowing to Prometheus, you can create or you can use existing Grafana. So you can go to Grafana. So you already created a workspace one. So you can go to Grafana and you can deploy the data source. So data source here, I configured the Prometheus workspace that is created with the EKS cluster. So you can provide all the basic information and add this workspace here, and then you can save and test. So you should be successfully able to query the Prometheus API to view the metrics. So once you add your data source, AMP data source, you should be able to see all the metrics flowing into the Grafana. So from here, you can choose all the metrics, all the critical one, and then you do have the ready-made dashboard JSON available in Grafana community, or even the Terraform, the observability accelerator. Once you deploy, you have all the basic dashboard with critical metrics, so you do not have to create dashboards from scratch. So yeah, so with agentless monitoring, we made the configuration very simple for customers to enable monitoring and start visualizing the data, as soon as your cluster is created. Yeah, so that's it from my end. I will pass it to Jagan to cover EKS governance.
Terrific. And then while we pass the baton to Jagan to cover EKS governance, Siva, curious if you were able to speak to a couple of the comments that some of the folks shared in the polling. I'm not able to highlight all of it, but I think some folks expressed some potential challenges with observability as it relates to upgrading, EKS versions, as well as it relates to cost allocation within one cluster. So curious if you're able to speak to either of those topics at this time.
Yeah, I think I'm not able to see the questions. Michael, can you really be able to speak up the questions that I can answer?
Yeah, I'll Slack them to you. These were through the polling, and unfortunately I'm not able to share it at this time. So I'll Slack it to you offline, and then if you want to comment on it, that'd be great. And then before jigging starts, I recognize that some of you may be more focused on the observability piece of the session. So just wanted to highlight the survey, if you're able to fill it out before you hop off, as we will transition the focus to governance for EKS workloads, which is an exciting topic, but recognize that some of you might need to hop off. I just posted a link to a survey. So if you're looking to hop off, please feel free to fill out that survey, give any feedback you might have for the session. This helps us improve and provide experiences that are helpful for the audience. And then lastly, I will be sharing one more poll, related to some of the challenges that customers may have for ensuring governance for EKS environments. So if you're able to provide that feedback as well, that'd be terrific.
Yeah, thanks, Michael. I will talk about on the questions part maybe after Jagan is done. Yeah, thank you.
Terrific. Yeah, we'll do that. All right. Jagan, the floor is yours.
All right. Can you all hear me okay?
Yes.
Okay. Okay, thank you all. So this section of the presentation, I'm going to talk about cloud governance for your EKS environment. So let's quickly talk about the agenda items. So I'm going to talk about some of the common challenges that customers face as you are, adopting EKS and AWS. We'll talk about what I'm, exactly meaning when I'm saying cloud governance. I'll talk about some of the EKS best practices and some other services to govern your EKS more effectively. So these are the agenda items, and then I'll go on a demo and showcase these features to you. Moving on. So striking a balance between innovation and security is one of the biggest challenge, right? So I'm going to talk about, in this presentation, I'm going to talk about, with the traditional governance model, it may not work in a cloud environment. We are talking about a highly dynamic resources. So it's important to have controls in place to ensure that your environment is safe, cost efficient, resilient, etc. On top of it, many of you may be working in highly regulatory environments, such as, and then you have to be mindful of compliance such as GDPR or HIPAA, etc. So in those cases, having these controls in place are becoming more and more important because they, you can't ignore compliance because there are laws, and then you will lose customer trust without those in place. So that's the challenge that our governance services try to address. So when we talk about governance, it spans multiple domains, right? Such as security, identity, cost, compliance, resilience, and operation. So while this is applicable across AWS services, I'm going to talk about specifically with EKS in this presentation. So the first thing you should be aware of is the EKS best practices guide. Our container service specialists have put together a EKS best practices guide, which has very specific recommendations, which are categorized under various domains, such as security, reliability, auto scaling, best practices. When you're running Windows containers, what are the best practices for networking, scalability, upgrades, and cost optimization. So I put a link here. Please feel free to bookmark this. This is kind of like the best place to start, as you are trying to implement best practices for your EKS cluster. On top of it, we have announced an open source Python-based CLI called Harden EKS. So the Harden EKS is a program, it's a CLI which automates the checks with respect to the various domains that I referred earlier. You're not required to be an operator to run an Harden EKS. I've linked I posted a link here which talks about Harden EKS in detail. The screenshot that you see here is a sample of the output that you can generate with Harden EKS. It runs various checks across various different domains like security, resilience, cost, etc., and identifies the issues that are in your EKS cluster with links to resolution. So that I would like to make sure that you are aware of this. This is one of the best starting points as you're implementing best practices for your EKS cluster. Moving on. So the next, Harden EKS is a great tool, and the best practices are done, per EKS cluster. But as you are looking at ways to govern your environment across your org or across multiple accounts, we have various services to help you implement these rules. So first, I'm going to talk about a service called AWS Config. I'm not sure how many of you are familiar with this service. So I'm going to give a quick overview of AWS Config as a service. So AWS Config is a service that records changes in your environment and normalizes and records it in a consistent fashion. So it is a service that runs on the background, records all AWS resources in your account. It offers a feature called rules and conformance packs. So what's a rule? A rule is something that you define, which evaluates your configuration against a certain set of best practices. A collection of rules is what we call a conformance pack. So you might have to implement several rules together. So that's a conformance pack. So as resource configurations change with time, the rule evaluations happen, and the config is able to generate events when a particular resource goes non-compliant. And then there is a feature within config called aggregator. So when you have multiple accounts, multiple regions, aggregator helps you collect that information into one view. So you have a single pane of view of all your AWS resources and their compliance in one single pane of glass. So that's an aggregator. And then config is connected to various other services such as SNS, CloudWatch, S3, and CloudTrail Lake. So what it enables you is to help you notify when things go out of compliance, compile list of things that are compliant or non-compliant. So you are able to achieve that level of information as well. So that is AWS Config. So let me talk about how AWS Config helps you with the compliance for EKS. So out of the box, Configs provides various rules for EKS. So here are some of the managed rules for EKS. So that is a rule which checks if cluster logging is enabled. You can check if the cluster is running the oldest supported version. You can check if a cluster's secrets are encrypted. And if you can check if a cluster is running a supported version and if there are any public endpoints. So these are managed rules that are available out of the box in the service AWS Config. So you are able to, once you enable these rules, you are able to generate alerts if a cluster is non-compliant across your org. In addition, config lets you create custom rules using, there is a syntax called guard, or it's a programmatic syntax which helps you create custom rules for your cluster, or you can create Lambda-based rules as well. So if your rule is very complex, you can create Lambda-based rules, and these rules will be evaluated periodically to make sure that your cluster is compliant or not compliant. So config is a service that can be used to govern your EKS cluster at scale. Moving on. I want to talk a little bit about another service that helps you with EKS governance. It's Control Tower. Control Tower, for folks who are new, is mainly, it helps you set up an AWS landing zone. This is for large customers who want to quickly set up and secure your multi-account AWS environment. It gives you a lot of design choices, helps you manage your organization more effectively. It also centralizes your identity and access controls. So, in terms of enabling identity and access across the org, this can be used as a single pane of glass. It also helps you set up monitoring, which allows you to plan and respond to potential incidents. So therefore, because it is part of a well-architected framework, it helps you automate the whole thing. The next feature of Control Tower is it automates provisioning of accounts in a compliant manner. So you can use Control Tower to provision new accounts. But last but not the least, you can establish controls across your organization. So there are three kinds of controls. Some controls are preventative, detective, or proactive. So these controls can be established across the org, which helps you to govern your environment more effectively. Now let's talk about so together these are this is basically Control Tower as a service. And now let's talk specifically about what Control Tower offers for EKS. So there are a couple of proactive controls that Control Tower offers. The first control is it requires an EKS cluster to be, so if you require an EKS cluster to be configured with public access, so if you don't want an EKS cluster to be configured with public access, you would enable this control. So the way it is implemented is using an AWS CloudFormation guard rule. So which acts at the time when CloudFormation is provisioning an EKS cluster. If it detects a public access to the API server endpoint, it would throw an error. The other proactive control that Cloud Control Tower offers is ensuring that you have encryption enabled on your using KMS. So if a cluster is set up without encryption, it would throw the CloudFormation guard rule would not let you do that. So these are the two proactive controls that AWS Control Tower offers with respect to cloud governance for EKS. Any questions? All right, let me move on to the next scenario. So I want to talk about another service that can be used for EKS governance. So it's CloudTrail, right? So CloudTrail is another service that is used for governance and audits to track user API activity across your infrastructure. So the use case is to capture and record activity as CloudTrail events. As you may be aware, all API activity in AWS, including EKS, everything that happens with your EKS service gets captured as a controlled CloudTrail event. These events are stored, in S3. You can also send it to other third-party SIEM operators as well. CloudTrail provides you various ways to trigger action based on a particular event. And then you can review the findings and then use that for an audit functionality as well. There is a feature within CloudTrail called CloudTrail Insights. So some of the core features of CloudTrail, event history, right? So you can access up to 90 days of control plane event history. There is no charge for this. But if you decide to have a trail, the first trail is free. The management trail is free, which gets delivered to S3 buckets, etc. And then there is we have a feature called CloudTrail Lake. So this is immutable data storage for your events. You can aggregate data from multiple regions/accounts and or even external sources, and it's an immutable storage for your data. You can query the events using a SQL-like syntax and visualize the audit logs. So this is another feature within CloudTrail. It's called a CloudTrail Lake. There is another feature called CloudTrail Insights. So once you enable the insight logs, you will be able to monitor anomalous activity across your AWS accounts. So I'll talk a little bit more about that as we, I'll do the demo. So the the generated insights would have, would be based on API error rates or API total number of events. So some of the best practices, just to note that all EKS actions are logged to CloudTrail for security and audit, security and compliance auditing. It's highly recommended that you use CloudTrail Insights to help identify, unusual activity within your account, and you'll be able to respond based on that. So the key takeaways with respect to EKS governance are, implement EKS best practices. So that is the fundamental thing that you will have to implement. Take advantage of the centralized governance controls using services such as Config and Control Tower. We talked about AWS Config rules and the Control Tower proactive controls. The other thing that you could do is set up anomaly detection using AWS CloudTrail Insights. So these are some of the fundamental things that you can do to make sure that you have good governance of your EKS environment. So I'm going to quickly pivot to demo. Before that, I'd like to pause for any questions.
No immediate questions that are unanswered at this time. We'll give a couple seconds for folks to share anything on the Q&A.
Okay.
And then one thing is I will post one final poll from the audience in parallel. So if the audience can provide feedback to that, that'd be helpful as we try to understand how to improve our services going forward. Oh, looks like we might have a question. Yes. Oh, Jigen, that actually was a good reminder. You shared a couple of links earlier in the slide. Could you, after your demo, could you share the links such as the EKS hardening script? It's difficult to copy and paste the links from the presentation. So when you're done with your demo, if you could share the chat, if you could share the links in the chat, that'd be helpful.
Yeah. Okay. Yep.
Perfect.
So I'm just sharing the best practice link before I just get started with the demo, and the harden EKS. Okay. All right. I'm going to share.
And then one piece of feedback we got from my previous poll was around outdated add-ins. Jigen, do you have anything to speak to supporting customers with outdated add-ins with our governance tools today?
Can you repeat that question? Was it outdated add-ins?
Yeah, so one of the audience members in my previous poll with regards to challenges with governance for EKS environments was outdated add-ins. And so I'm wondering if you could.
Yeah, if you can talk a little bit about what you refer to as add-ins, that would be helpful.
Okay. Well, if there's an attendee that provide that input to the poll, if you could share in the Q&A with more additional detail, then we could try to speak to it. And then meanwhile, I'll post my final poll for the group in case people are able to provide some feedback as we improve our products going forward.
Okay. So first, first I'd like to talk a little bit about the EKS hardening tool and how it is run, right? So I'm just going to go and run that for you. I'm just going to show you a syntax of how it's run. So it's pretty straightforward. I have the lab running from EKS workshop, and then I'm just running the EKS hardening tool. It's pretty straightforward. The syntax for running this EKS, the harden EKS is right there. It's documented very well. So give me a second. I'm just trying to find that command here. Yeah, so this is pretty much the command, harden EKS. You specify the region, and then you export the output as a HTML. You run this against environment, and that's going to generate an output for you, which kind of looks like this. It's super detailed report of your EKS cluster, documenting all the findings. If there is something that's, it identifies an issue, it highlights as a red, and a link to the EKS best practice guide, and which talks about what's wrong and how you would fix it. So yeah, like I said, for governance, this would be the best starting point. You start here, gives you very good details on, I just flipped the screen. Give me a second. Yeah, it gives you a very good details on every rule that is being checked by this, and our containers team is adding more checks as we are identifying them. So that's the first part of this, and then the second part I talked about using AWS Config, right? AWS Config rules. So within AWS Config, this is the service. You can see a dashboard. You can see the compliance of various resources. So I'm going to show you an example here. I'm going to search for EKS cluster here and apply. So I do have this EKS cluster running. So as you can see, currently, these are the rules that are applied for my EKS cluster. And an AWS config evaluated these rules against my EKS cluster, and it has been able to identify that these checks are compliant and these following checks are non-compliant. You will notice that there are some duplicate rules, but it did identify that some of these rules are non-compliant. So in terms of what AWS config records for your EKS cluster, so here are the details. So every periodically, anytime anything changes within your EKS cluster, the entire EKS configuration is recorded here. So basically, if you're writing a custom rule, you are able to create a rule based on any of these components here. So what I'm going to do in this demo is, so as of now, we notice that the EKS cluster logging has not been enabled. And so config was able to identify that this cluster is non-compliant. So I'm going to go to the EKS console, manage logging, and I'm going to enable logging. So this particular checks only if audit logs are enabled. So I just changed the audit logging. I enabled audit logging. Let me refresh the screen. Maybe it's not refreshed. Yeah, the audit logging is on. So if you go back to AWS config, we should see shortly that this rule becomes compliant because we did enable logging. So this is how config works. So it keeps, anytime there is a change in an AWS resource, in this case, an EKS cluster resource, AWS config records that change and validates it against the rules that are deployed. And in this case, because we have this rule, it's going to check against this rule, and it's going to report that it is either compliant or non-compliant. So because let's give it a little bit more time, we will see that it'll change to being compliant. I'd like to pause here for any questions on config. I know this is a lot of, AWS config is a huge service by itself, but I just wanted to talk at a very high level on how you can use this service to govern your EKS cluster. Again, let me see.
Going through the Q&A. Yeah, no additional questions. Looks like you're doing a great job running through the capabilities.
Okay. So let's just pivot to CloudTrail before we get back to this one and check on this. So CloudTrail is another service that I talked about. Give me 1 second. Let me launch CloudTrail. Oh, it's right here. So CloudTrail is able to record various events. So if you go to events history, you can search for all the events originating from all all AWS API activity, including EKS. So event source, you could say EKS, and you would see all the events with respect to AWS EKS resource type. So you could see EKS list insights, so all events are getting captured. So what I also did was I enabled a new trail for capturing insights So if you go to all the trails here, I do have a separate trail for capturing insights. So when you set up a trail, you can enable management events, data events, and insights events. In this case, I have enabled insights events. So the insights events is able to generate this. So anytime an anomalous events are detected, insights would identify and alert it here. If you so the way you can get alerted for any insights is by having this trail being sent over to CloudWatch. So you can enable CloudWatch logs for your CloudTrail events. This way, the CloudTrail event gets streamed to CloudWatch, and then from our CloudWatch you can set up alarms when a particular condition is met, or when a particular metric is when you see a certain anomalous events getting generated in the insights. So these are some of the services that AWS has to manage your EKS cluster at scales. Any questions so far? Okay, so I'm going to pivot back to config and check on these rules that we configured. Let me see. Yeah, as you can see here, the cluster logging enabled has turned to compliant right now. So if you see the resource timeline, you will see all the changes that happened, and you will notice that right now the cluster logging is marked as compliant as of now. So because the log type was set to audit and I enabled the audit log, this particular rule has turned to compliant right now. So that's a quick demo of how you can use AWS config rules to govern your EKS cluster. That is all I had for today, unless there are any more questions that you'd like to talk about.
Yep. Thank you, Jagan. I think we have some questions. Maybe I will take some time to answer some of them. I think we have one of the questioners. What are the biggest challenges you have with observability for EKS? So I wanted to talk about some of the responses and then how we can do it, right? So starting with alert fatigue. So this is one of the common question we are getting it from customers. So most of them, like, they don't know, or like, either they are creating too many alerts or too few alerts. So from AWS, like, during the last reInvent, we have introduced something called alarm recommendations, or out of the box alarm recommendations. So what it does is, like, we are providing some kind of recommendation from our side based on operating our cloud for the last decade or so. So using this as a reference, you can get started with your alarm recommendations. So this is one of the options available for you. And then the second question on container insights and then log insights. So many of the time, like, people, like, especially if they are coming from development side or like business side, if they wanted to know more about, okay, what are my top 5 slowest queries? So I wanted to know, right? But unfortunately, like, if you wanted to go ahead and then query in container logs, like, you need to use the DSL, which is a domain specific language, and then you need to write it. So with this, like, a latest addition, that is thanks to the GenAI, we have that natural language query generation. So this is coming for, like, CloudWatch logs and metrics today. And then we are adding it more and more, like, even today, like, CloudTrail insights, this is applicable for you. Now you don't have to know about, like, any of the languages that you need to do. Just use this as a natural language. Go ahead and then ask the query. Say, like, show me the last 5 slowest queries, and then it is going to give you the query. And if you're comfortable, like, go ahead and then make the changes and run it, or like, use it as it is, right? So that is one of the option available for you. And the other option is, like, cross account monitoring, especially, like, people are running multi accounts, and then when they wanted to enable this cross account, how they wanted to do it, right? We do have some resources. As a matter of fact, like, last webinar that we hosted, that Michael hosted, was about cross account monitoring. Please go ahead and then look for that recording from YouTube. You should be having it. So we do have, like, this unified cross account monitoring, wherein we are providing the CDK and stuff. Just enable it and then identify a single monitoring account, wherein, like, all your logs and metrics will be populated, and from there, like, you should be able to do it. And the good news is, like, you are not transferring the data from one account to another. So there is no cost involved over there except traces. Only for the traces, like, you will be charged for that. So that's an pointer that you can do it. Then people are talking about, like, the next question is on, while upgrading the EKS versions, people finding it difficult. Again, from the last year, we introduced something called Upgrade Insights. So if you're running, like, version 1.27, and then if you wanted to go to 1.30, as usual, like, in EKS, like, you need to do, like, one version after another. So with Upgrade Insights, like, it is going to give you, like, how it is going to be behaving, which version you are in, how you are going to be doing, and all those things. So Upgrade Insights is one of the recommended way, I would say, like, you can do it. So the next question is on open source integration. I know many of the customers are running, like, Prometheus and Grafana. That is Amazon managed Prometheus and Amazon managed Grafana, but they are finding it difficult when they are running, like, across accounts, because they need to do it for each and every cluster and all those. So we hear that feedback from the customer, and recently, like, we came up with a solution, which I just put it in the chat, that is enhancing the observability using managed monitoring solution. So what this solution does is, like, we will be giving you just a CDK or CloudFormation. If you have, like, EKS cluster and then Prometheus and Grafana available, like, maybe you can use a Terraform or, like, whatever the IAC tool of your choice. So just create the cluster, create the workspace, and then for Prometheus and Grafana, and use this tool. And what it's going to do is, like, it is going to create some dashboards for you from your EKS cluster as a source. So then it will be using that Prometheus, like, sending the metrics to Prometheus, and then you have, like, some pre-configured dashboards available from Grafana, so that you can use it, so that you can do it. And last question is, like, this is what, like, we have been getting a lot from our customers. That is, monitoring features provided by AWS is not great compared to third-party solutions like, New Relic, Datadog, etc. So there is no, like, one answer for this, because you as a customer, like, might want to do something, but that could be available from some third-party providers compared to CloudWatch, etc. And that's what we talked about today. That is application signals and container insights. So application signals is our way of doing applications performance monitoring. So the way I have demoed today, you just need to click that, like, and I just enable the CloudWatch application signals from, like, in EKS. It's just an add-on, right? So once you enable the add-on, you don't have to do anything. Again, based on the OpenTelemetry standards, it is going to do, like, runtime. It's going to take the metrics and traces and send to CloudWatch. So this is a way, like, we are planning to go forward with application signals. And so just last week, application signals was GA'd, and then application signals has very tight integration with container insights. And using that, like, when you're running your workloads in EKS, and then if you wanted to do something with, like, the observability, application signals will be an easy option for you. So these are some of the questions I got from the chat, and I just wanted to provide some pointers. So the thing is, like, it is not stopping here. Please talk to your account team, AWS account team, and then they, I mean, if you have any further questions, and then if you wanted to run any kind of immersion day or something, so that, like, if you want your team to be equipped, we can run some immersion days and game days, etc. So make sure, like, you guys are familiar with all the observability tools within AWS, whether it is, like, whether AWS native way of doing stuff, or, like, open source way of doing stuff. There are a lot of options for you. So with that one, like, any more questions, please go ahead and then put it in the chat.
Sounds like we might be good on the questions. What I will do, just to just to give some folks some time to upload any final questions, I do want to also highlight a quick reminder if, before folks head out, if you could please fill out the survey. I just posted the link in the chat. And then let me go ahead and share my screen one last time. So yeah, really appreciate everyone's time here to meet with us and learn more about AWS's native capabilities. This session is being recorded, and it'll take some time, but we will look to upload this recording to YouTube for future reference. So no need to worry about that. And if you have an AWS contact, please feel free to reach out to them for some additional support. If you're interested in learning more about AWS's native tools for observability and governance. So with that, I will go ahead and end the recording. Thank you everyone for your time again, and I hope you have a great rest of the week.